Hello and welcome. We are going to take a look at a new topic today called objects. So now that we have our basis of Java, either we're getting caught up with Java or, it's a nice review, we're moving on to some new stuff. So let me just get going here. We have a couple of learning objectives that we're going to cover here over the two sets of notes that I have. So we can see the ones in bold here that are going to be the learning objectives that we actually cover with this video. We're going to learn to write simple to moderately complex classes. We're going to learn about constructors, instance variables, and instance methods. We're also going to cover the this keyword. We're going to learn how to compile and run Java code with multiple files in the same directory. We're going to use instances of our user-defined classes. And we're also going to use our user-defined classes inside other user-defined classes and in our main methods. And then everything else here we're going to cover in the next video. So OOP stands for Object-Oriented Programming. And it's a type of programming model that's based on the construction and the use of these things called objects. Now, a program uses a set of objects for interacting together, a little bit like the real world, just like how you're probably sitting on a chair in front of a desk and your computer is on that desk. Each of those things could be considered as an object, and they're all working together to allow you to watch this video. Lots of different programming languages inherently support object-oriented programming. And so we're going to see sort of the basic concept of these objects and how they work in Java. In your next year of computer science, should you continue, you'll learn in other courses more complicated topics surrounding objects and how they work and the real power of them. So the very first thing we have to start with is we have to talk about this idea of a class. We've been talking about classes where we put our main method, and we've sort of just been taking it for granted. We didn't really talk about what it actually was or what it meant. But it's actually not just a container in which we put our main method. It's actually like a data type, just like an int or a string. So when you create a class, you're actually defining a new type of data. Just like any other data type, your new type has a name, right? So just like string has a capital S, we want to make sure that our classes have a capital case name, which is something that we've already been telling you should do. So just like string S has a capital S, technically that is the string class. When we make a new program, we want to do the same thing. Also, our new type will have some kind of information that we want to store in it. It's a bit actually like it's a collection of information typically. So when we think about a string class, not only do we know how, like what the string is, like the word, but we also have information on the length of the string, or specific characters in the string, stuff like that. More to come on that in a few weeks. So we're actually storing a collection of information, and this is typically called instance variables. So instance properties of the class. We're going to learn about class variables later, but those technically exist as well. And then also some kinds of behaviors and actions where we want like the different types of actions and behaviors that we would want to perform given the collection of information we have access to. So this is a collection of information called instance methods. So these behaviors and actions are associated with methods, and they're called instance methods. And then the information that they often do work on are called instance variables. And again, there is another layer to this called class variables and class methods, but we will talk about that in a little bit. So objects of our new data types are often used to represent real life objects, just like a chair or a desk. We can say a chair has, 4 legs to it typically, or Boolean rolls around, right? Has wheels, things like that. So similar to other data types, we have access to all sorts of information. It's just a little bit more complicated than what we did before. So imagine for a second that we're going to talk about like a person. I'm going to see if I can continue with my screen moving stuff here. Let's open a new folder in Visual Studio. I'll just put it on my desktop, pardon me, objects, I'll just say objects example. That seems like a fine name. Oh, I like to usually put a dash, so we'll do that. We're going to open this folder, and then we're going to go ahead and make a new file. And this is just going to be the main class for a second. So we're going to make a new main class. public class, my program, and then we can say main. Now, imagine for a second if we wanted to store information about a person could have a name. We can just use myself for now. And we could put, oh, that didn't work. Hold on. The Zoom bar is in my way while I do this. Of course it is. Okay. Let's move this back up. Sorry about that. And we have an int age, which we can say 30. 20 would be nice, wouldn't it? And there we go. And we can store like a person's information in our main, just like this. But these are individual pieces of information. And what a class is actually going to give us is the ability to group this information together so that we can sort of group all the defining characteristics of a data type in one object. So with a user-defined tree, tree class, for example, we can make object variables like tree oak or tree elm. So if we're going to make a person one, we can make a person instructor or a person student or a person child. Variable, just depends. So let's go ahead and actually create this data type, this person class that we've already started talking about. So right now I have it in my main where I'm making these two variables and want to be able to print them out. But that's not actually how we're going to do this. When we make a new data type, when we make a new class, we want to make a brand new Java file with that information in it. So let's go ahead and add a new file here, person.java. And then it is going to be public class person. You have one public class per file. And we like to work under the assumption that you're going to have only one class in each file as well. So the public is always there, public class person, person has to match the name of the file, person.java. And then we can, rather than declaring these variables in here, we're going to put them in here. String name, whoa, that was weird. String name, int age. So now we're sort of creating like a little box. Well, I guess it's a big box that we're saying, okay, these are the things that are associated with a person. Now, it's important to know that at this point in time, this like class file, this person.java class file, is more like a blueprint or a model. Like if you think for a second, a bit like it's a weird example, but like Lego building. So if you have like a machine that like builds the Lego bricks, like actually makes the Lego bricks, not building a big structure out of them, but like singular Lego bricks, there is a mold that exists somewhere, I'm guessing in Denmark, where the like melted plastic goes into the mold and then the mold closes on it, forms a Lego brick, and it comes out the other side. And so we only have one of those molds. The mold dictates exactly the properties of the Lego brick, and as we feed the material in, Lego bricks come out the other side. The machine itself isn't a Lego brick, it's just sort of the blueprint for Lego bricks. That's very similar to this. This class definition is really just like a blueprint or a model for our new type. It doesn't create anything in memory, and it doesn't really give us anything that right now we can use directly. When we actually want to create an instance of this class, that's when we get an object. So let's talk about how we're going to do that in just a minute here. We can see that we're defining this new data type, and internally, oh, I forgot to add the public keywords. We're going to get rid of those very soon, but for right now, we're going to put them here, saying that anybody can reach these. Okay. So these two pieces here, this string name and int age, these are instance variables. It's the object's data. So every time that we make a new type of object or a new person, each person variable has its own name and its own age. And if we think again back to that Lego model sort of example, imagine for a second if we were building like 2x4 Lego bricks. I feel like this should be relatable, but now I'm nervous that like maybe it's not relatable. So let's just really quickly look at like a 2x4 Lego brick, just so we can know what we're talking about here. Here's a great one. I don't know why it's literally $17.99, but that's fine. Here's a 2x4 Lego brick. Imagine a mold created this. We understand that if we make 5 different Lego bricks, each one will have 2 rows, or I guess 2 columns and 4 rows, depending on how you look at it. 2 rows and 4 columns, right? Every single Lego brick has its own set of 8 buttons on top, within 2 rows of 4. So we totally can see that when we're looking at a Lego piece, right? It's not like all of them share the same 8 buttons. That wouldn't make any sense. That'd be like conjoined twin style. Each one has its own unique set. That's exactly what we're talking about here. We're saying that each instance of the person class, just like each instance of a Lego, has its own set of values, has its own set of buttons. It's very similar to the data inside of an array, just like how we have a single array, but each element has its own set of data. And we're going to, like I said, talk about that public later. Now, we're going to talk about constructors in a bit, but for right now, we are going to work under the assumption that this is actually our whole class file. Normally, these variables will not get assigned in the way I'm about to show you, but just for the sake of building our basic understanding, and then we'll build on top of that, we're going to start with a very base principle. Basically, don't stop watching after this because we're going to learn a much more efficient, better way of managing these new objects. Okay, so let's talk about this defining of our new data type. So we have our person.java class. When we compile this class, we'll see what happens. We end up with a person.class file, just like when we were declaring, when we made our main class and we compiled our code, we had a main Java file or a main class file, pardon me. And just like strings and ints and booleans and everything else, when we want to make a new instance of those data types, we just say data type and then variable name. We are going to do the exact same thing here, and we're going to make some declarations. So let's take a look at that over here. Rather than string name int age, we're going to say person, instructor. Now we have to understand that this is just a declaration, similar to how if I did this, string s, that is just a declaration. If we want to initialize this, or int x, right? These are all declarations of variables. If we want to give these values, we want to assign them a value or give them an initial value, we can give them an initial value like this. Whoops. If we don't give it an initial value, it does actually have some kind of a default value. Now, data types that start with a capital letter, like string s or person instructor, those are going to have an initial value, meaning when you don't have an equal sign, an initial value of null is actually what it's called. So you'll see like this, null. Integer, other primitive types, so things that start with a lowercase letter, primitive or lowercase data types. That's not really a technical term, but just to help you remember, primitive is the real term. Primitive defaults are typically garbage. Now, sometimes they can make sense, like an integer one is typically just 0, but we can't always rely on that. So typically we don't want to rely on defaults. Point being that this by default is just going to be null. So instructor right now equals this magical value of null, which basically means the absence of a value. There's nothing there. If we want to actually give it real values, we do it a little bit differently. We use here what's called dot notation. You'll see here that we're getting an error because we haven't initialized it. We're going to talk about that in just a second. But we use what's called dot notation to give things values instead of what we were doing before. So we say on the instructor, we're going to give it a name, and the name is going to be Lauren. On this instructor, we're going to give it an age, and it's going to be 30. If we wanted to do like one of my kids, I guess, we'll say kid 1. We would say kid1.name is equal to, whoa, I can spell, Evan. Kid1.age is equal to 5. Oops, that shouldn't be a string. Should be like, I am so good at typing. 5. Okay, we can still see that we're going to have some errors here right now. This isn't going to run, but I just wanted to show that we can have 2 different people objects. We have person instructor, person kid1. Each one using what's called dot notation can access that object's instance variables. So the instructor object's instance variable name and the instructor object instance variable age, or kid1 object instance variable name, kid1 object instance variable age. So they're two unique objects, each with their own information stored inside their instance variables, inside those properties. Now, this doesn't run right now. And as we can see, the error message here is saying the local variable instructor may not have been initialized. And this is actually a really helpful error message because here we did not initialize S, right? We didn't give S an initial value. And here we didn't give X an initial value, but they each have defaults. When we say instructor.name, and instructor.age, we are not initializing instructor. We are initializing the string inside instructor or the age inside instructor. So the actual object here isn't being initialized right now. We are missing something. So even though these do have initial values, this instructor right here is not the correct. It's currently nothing. It's currently null, right? We said that anything that has a capital letter, its default value is null. And so then what ends up happening here is if we end up trying to call instructor.name, just like calling s.length, when the value is null, we'll see what happens is we're trying to basically say null.length or, null.name. And you can't do that. That is not a thing. And your code will crash when you're trying to run it. So we have to somehow give this an initialized value. So that's what we're now going to look at. So just in notes here, when we create a new variable, we do that declaration, we end up with no assigned value right now, right? So they are null. All variables of an object type are containing what's called a reference, not the object itself. So we've seen this with arrays, and we've actually seen it with strings too, because these are all objects. Our user-defined types are also objects. So our variable Morrigan or our variable Lamia right here, or our variable instructor, our variable kid1, those all by default are sort of just like placeholders when Java goes looking for the information inside the placeholder, those variables can say, hey, go look over here. It would be very similar to you coming to me and asking me where I live and me telling you where my address is and telling you where to go find my house, as opposed to me carrying my house around with me so that anytime you come to see me, you can also see my whole house. That's kind of the difference here. So Morrigan and Lamia right now are just pointing to null. They're both saying that they don't have an assigned value. That would sort of be like if you came to see me and said, where do you live? And I said, I don't have an assigned home, right? I don't have an address. That's kind of like what it's saying. Right? So you can also consider these references, these addresses that I'm discussing, a little bit like a library book call number, where each book has its own unique call number, like based on the Dewey Decimal System or whatever. If two people have the same call number, then you're looking at the same book, right? If you asked me where I live and you asked my husband where I live, we'd actually give you the exact same call number. We'd give you the same address. You'd come to our house, you'd be at the same house. If somebody scribbles, if my husband goes home and like sets our house on fire, I'll be like, why is my house on fire? Right? If we have the same address, when we both go home, we're in the same physical location, and any changes he makes to our house, I'm also going to see. Similar here. If somebody checks out a library book and then scribbles in it or tears out pages and takes it back, and then somebody else gets that same call number and goes to take out that library book, they're going to see the same scribbles all over it. So we'll learn more about this, but what we call a shallow copy, it's two different references pointing to the same physical location. However, there's a different situation here where we could also have two copies of the same book. Like if you actually go and buy, I don't know, a Harry Potter book or something like that, a bookstore probably has 5, 10, 15 copies of the same book. Here, each book has their own unique call number, which would basically symbolize individual separate copies of the same book. So then if I have a copy of Harry Potter and I scribble all over it, you can have your own copy that is not touched by my destruction of property, right? If I didn't, the copies are identical, but of course yours is untouched when I do horrible, unspeakable things to my copy of the book. Okay, So when we create an instance, like an actual object, we right now are missing this part. We need to create, we need to call a constructor, which constructs the object. So this creates the object in memory and it will return a reference address pointing to it. It's kind of like builders going to the plot of land that I purchased and building my house and then coming and saying, hey, the house is built. There's nothing in it yet, but like there's rooms and there's a kitchen space and there's roughed in plumbing. So the framing is all there. But it's not that helpful right now. It's kind of useless. There's not really a lot there. So we can do that here. And we do that by saying, by using the new keyword, capital N, new, and then the name of the class. This is exactly the same as what we do with arrays. If we make an integer array, and we say new int and we give it a size, whatever it might be, we'll notice that this is the data type. And then we can say new that data type. It's a little different, round brackets, square brackets, but the new keyword isn't actually all that new to us. I'm so funny. Okay. Anyway, so it's a bit like building a house. And then at this point in time right here, instructor name is null. And instructor age is probably 0, but it might be garbage. So this is like that builder coming to say, hey, your house exists, but there's nothing in it yet. If I want to go and fill things up in my house, like actually put a bed there so that I can sleep, or like a shower so I can get clean, I'd have to go to the house and add the shower, or go to the house and add a bed and give those things a true value. So here we're going to the instructor object that we created and we're giving it a name. We're going to the instructor age and we're giving it an age. And we can do the same thing here. We can put another person in memory, kid 1, and then we can physically go to that kid 1 and say, your name is Evan, your age is 5, because by default, kid 1 doesn't have any information. It's just sort of like, in my head, I'm like picturing like Slender Man. Like I'm picturing like a faceless, nameless being that is technically a person, but there's no use right now. Like there's nothing to them. Um, Maybe that's a weird analogy. That's kind of what I'm thinking of in my head right now. Okay, so now we've gone ahead and we've actually built the scaffolding for this object, and then we can access the information inside of it using dot notation as we've done. Now, the reason dot notation works is because we did put that keyword public in front of the instance variables, and we're going to get rid of that later, but now we can use them just like any other variable. We can use the names of the different people as names. We can use the ages of the different people as ages. So if we want to come here and figure out who's older, we can say that's all capitals. If instructor dot age is greater than or equal to kid 1 dot age, then we can say something like, oh, I don't know why it always defaults to the error one instead of the out one. The instructor is older than a child. It's good news, right? That's sort of what we want in an instructor, is them to be older than a child. When I go ahead and I run this, we'll see that it does indeed go into that if statement, since instructor age is 30 and kid 1 age is 5, and we can say that the instructor is indeed older than a child. Okay, so the next thing that we can talk about here is we can talk about instance methods. Now that we've seen 2 instance variables, let's move on to discuss instance methods. Instance methods are methods that we can use on these instantiated objects, these instances of the person class, or whatever your user-defined class is. These methods have access to the instant variables of that specific instance. Again, this is as if I were going to go into my house and take a shower. I wouldn't end up in one of your houses. I follow my address. I go to my own address, my own home, and now I have access to the stuff inside my home. Can't touch the stuff inside your houses. I'm not inside your houses, right? I am inside my own home. So these are defined very, very similarly to other methods that we've seen, but there's just a little bit of a tweak that we're going to do here. The first is we're not going to use the static keyword, and we'll talk more about that later. And then the second is we have to make sure that we add the public keyword, which we didn't have in the main class. And we're going to talk more about that a little bit later as well. For now, we're just going to assume that those 2 things are things that we care about. Now, of course, Person.take shower maybe doesn't make as much sense. It makes some sense, don't get me wrong, but perhaps something that makes a little bit more sense is something that a person can do. A person can have a birthday. They can get older, right? Have a birthday. And when a person gets older, their age goes up. We can see that happening right here. This makes a lot of sense now because, again, imagine for a second that we are physically the person that we're talking about. This is the blueprint of things that you can do with people. But when we actually use this have birthday method, we're going to be using it by talking about a specific person. We're going to go to that person's home and throw them a birthday party. So we're going to see how that works just one moment here. We can two different instance method examples in this class. We have birthday, and we also have get letters in name, right? How do we actually use these now? I'll show it first, and then we can go through the slides. So if we're in my program class right here, right now, if I print out some information and I say kid1 dot name, so this kid is blank years old. If I do this, we should end up with kid 1 being Evan. Evan is 5 years old. So we do get that line right down here at the bottom. Now Evan's about to have a birthday. Kid 1 dot have, whoops, not hash code, have birthday. And there we go. This is how we do it. It's exactly like when we were calling string dot length. When we call, let me just make two strings very quickly here. Hello. And string 2, hello 2. And then we try to print out s1.length. This one is going to print 5. I can count. System.out.println. And if we say string 2.length, this one is going to print 6. And we sort of take it for granted. It's like, well, of course, s1.length prints 5 and s2.length prints 6 because hello has 5 characters and hello 2 has 6 characters. And we just sort of take that for granted. But sometimes it becomes a little bit trickier when we talk about it with respect to our own user-defined classes. When I say kid1.haveBirthday, it's literally this kid executing this method. And this kid, this instance, kid1, has an age of 5. So when we say kid1.haveBirthday, inside here, this age variable actually does equal 5. And then we can say have birthday age plus plus. That variable is going to go up to 6 now. So they're going to be 6 years old. And so then if we try to say this same line of printing again, I'll just leave the string stuff in there for a moment. We now are going to hit 6 years old. Evan has aged up. Evan had a birthday, right? So it's exactly the same as what we did with strings, where when you call dot length on one string, call dot length on another string, and what we see happen is the age go up. They're two separate strings. Another nice way to sort of envision this, if we're struggling right now, is as if we were to say, this part's a little bit different for strings because there's an equals, and we don't really need an equals. I'll show how to make it seem similar. If we did it like this, we would have a string length of 5, and then the same object has an increased length now to 6. Now here you can see we have like the equals, which makes this maybe look a little bit different, but a reminder that age plus plus is exactly the same as saying age plus 1. We can see age is equal to age plus 1. And here we're saying s is equal to s1 plus the new string. There isn't really like a function where you could be like s dot append on a 2 or whatever. Like that just doesn't really exist for strings. You have to say it with like the plus operand. So that's kind of maybe why it looks a little bit more confusing, but it's just because there is no instance method to attach something to a string. You just use straight up plus. Whereas with our person object, there is an instance method to engage with the age character, with the age value, right? We have .have birthday. We added that method. Oh, that deleted everything. Whoops. Okay, we can get rid of that string stuff now. All right, let's keep looking here. So we added our have birthday, and we've also seen now how somebody's birthday may increase. So we don't have to go through this again. Here we can see that this instance method is being applied as an operation to a particular object, just like strings, just like have birthday. This instance method is returning a value, it's returning an int. And so here we can see us storing that value into a variable in the main method. The instance methods are being called on a specific instance, and so they have access to that instance's instance variables. That was a tricky sentence. So you'll notice that we did make two separate classes. We made them like our main, ours is called my program, but whatever, and a person.java. And we can see that each class has its own file. These files must live in the same folder directory on your computer. And then when they're compiled, we end up with a different .class file for each of our .java files. When I say files must be in the same folder, even more specifically, in order for your program to comfortably see the different files, if you're using VS Code, you need to open the folder that they're in by calling open folder. Don't just open them one file at a time. Actually go through this Explorer right here. This tells you where you are, this Explorer window, and open the whole folder. So then that way VS Code can actually make sure that it's connecting the different pathways to the files properly. You might have trouble if you don't do that. Okay, we can get rid of these so that we don't have any more errors in here. Okay. So when we're actually looking at under the hood here, we can think a little bit about this have birthday as if it's like passing in the function, or sorry, passing in the object that we want to be performing stuff on. This one right here is not what's happening in Java, but actually other languages do work this way. More specifically, they work like this. It's a bit like saying public void have birthday person. See this keyword here is blue. Let's just pretend for a second. This is just a normal variable, and we would be saying this.age++. It would be a bit like code that looks like the following. Imagine if we had a method here like public static int length string this s. I don't know if it's going to be okay with that. Let's just see. Yeah, we'll say this s so that it doesn't yell at us, because that will help. And then we can just say length hello. Right? Nobody does it this way. That would make no sense. But inside here, we say this s.length, and we return that value. Return. Right? So we're passing in the string inside this method. We can say this string.length, and it will return that value. But that's really silly. That's not how we need to call for classes. We can actually just call it directly on the variable itself, like this, hello.length, or the string name.length, or whatever it might be. That's exactly the same thing as what's happening right now with our user-defined objects. So we're not actually using it like this or like this, but effectively it's the same thing. We're just using it using this dot notation. Okay, so in an instance method, such as our have birthday, or this one is like update a name or give a child a name, whatever it might be. If you have a local variable as a parameter with the same name as an instance variable, the local one gets used first. It's called variable shadowing. Okay, it shadows the instance variable. So imagine for a second that we had a a method right here called public void new baby name. Okay, so somebody is born, they're a brand new baby. We'll say string name. And we want to set the variable name here, right? Like we want to set an object's variable name to be the name that's coming in right here. It's going to get confusing. So yeah, that line will do nothing. That's fine for just a second. So imagine for a second, I go ahead, I have my second kid, person, kid2, new person. And then I want to say kid2 dot new baby. And I named my second baby Allison. So now when I go to print out Allison's name, I could say kid2 dot name is born, because that's the baby that we just gave birth to. And if I try to run this, I don't even know if it'll let me run. Let's see. It's going to let me. Oh, there we go. It let me run, but look, it says null is born. It didn't say Allison is born. It says null is born. And the reason being, when Java runs this method, this dot new baby name, it passed in Allison right here. And then when I said name equals name, Java looked at the left-hand side of this and said, where is there a name variable? And Java is lazy. Java is not going to look past the closest spot it has to look at, right? If somebody was like, hey, look at how beautiful the moon is tonight, you would look up from the sky and you'd look at Earth's moon and you'd be like, oh, yeah, it looks great. You wouldn't be like, are you talking about Mars's moon, Venus's moons, Jupiter's many, many moons? I don't know if it has that many moons. I don't know that much about space. Point being, you would never look past the closest moon because that would be ridiculous. Java does the same thing. It's not going to look past the closest name. So it sees this name right here, and it says, you must want to assign this name here to this variable name here, which, as we can tell, is literally doing nothing. So we have a few options to solve this problem. Option one is just give this a different name, like give this new name. So now when Java looks at this code, Java looks for the name and says, where is there a name variable? And it doesn't see one around it. So it looks up in the sky and it will see this one. And now it understands, okay, you want to be setting this instance object's name to the new name. That's option one. Some people like that. Some people don't. There's another option. Option two is to leave this as name, except now you have to find a way to disambiguate between these two name variables. So we use the keyword this. See, it turns blue, and we can use dot notation here. And now when we say this dot, we are talking about this instance object, the instance object that we called the method on. So kid2, that object, has a new baby name called Allison. We come into that method. Where is it? Person right here. And the name that came in through the brackets was Allison. And then this dot name is going to refer to this instances dot name. That's going to become Allison. And so now we will go from what before said null to Allison is born, even using the this keyword and not having to have a different naming variable here. Now, it's totally up to you how you want to do this. There aren't really any specific rules around it. It's pretty standard, I will say, to keep the name the same and then use the this keyword on this side, but you're not going to lose marks if you choose not to do that. If you choose to just give this a different name so that you can just say name equals whatever, that's fine. The only thing that isn't okay is if the variable name that you give it is something completely useless. So like new name or baby name or whatever it might be, right? Like it just has to be a useful name for this to actually, for you to not lose marks. But you can do it however is totally fine. Okay, so you can use the keyword this to represent the current instance of an object, right? The one that we called it on. And now we have this awesome availability of this dot name not being shadowed by the local variable name. This is used to specify that you want to access the instance variable for the object that the message was being sent to. Okay, cool. We actually didn't get a compilation error, which is super interesting. I would have thought we were going to get a compilation error, but we actually didn't when we ran it. This is an example of it happening on the age variable, but like it doesn't really matter, age, name, whatever. Point being, it just said null. It was just like, I don't know what you want. I'm just going to do the defaults here. And we didn't get what we expected. I thought it would give you a compiler error, but it didn't, which is interesting. But it did give us a warning, right? We did see the warning that when we got rid of this, we did get this warning, but it still did let us compile. It just says, you know, the assignment to variable name has no effect. Not the most helpful error message, warning message, but at least it's something. Something's better than nothing, right? Okay, anyway, here we can see how it was fixed. Using that this keyword disambiguates the problem. Whoops. Okay, so now we've set all of our information and we've given our person a name, we've given our person an age, and now we're going to go ahead and we're going to try and understand how we can print out this information. And we've actually done this already, right? If we look at our main program here, we actually did do those print statements. Here, we had a birthday, we printed somebody here. We can do that here for kid 2, kid 2, kid 2, and we can do one more for the instructor as well. Should have called it like mom, because like I'm the mom, but whatever, it doesn't matter. Anyway, anytime you find yourself copying and pasting as I'm doing right now, ask yourself, there must be a better way. What is the better way? Because that's kind of what's happening right now. So let's go ahead and take a look at that better way. Because if we have 10 person objects, am I going to sit here and write these same 3 lines for every single one of those person objects? That's insane. That's 30 lines of code that are unnecessary. So that we do have ways to handle that situation, so that we aren't cluttering up our main space here with the same line of code over and over again with the same .name and .age for every single individual. We do have a way around that, and we are going to look at the way around that right now. Okay, so how are we going to actually print out this information in our person object? Well, we can just, instead of that long string every single time, wouldn't it be nice if we could just put the object in and print it out, just like we do with a string or an int or a Boolean or a double, right? If we have a string, we'll do it down here. Whoops. My very great string names, and I say hello. All I have to do is print S1, and I'm going to get hello. So wouldn't it be nice if I could just say kid1 or instructor, and I could get the information printing the way I wanted instead of what's happening right now? Well, let's go ahead and take a look at this. What I'm going to do is I don't want to delete all this. I want to be able to give you this code, but I am going to do this just so that we can sort of hone in on the one line that we're currently talking about running here. Let's go ahead and push run. And we can see right here what actually, oh, get out of the way, bar. There we go. We can see what actually printed here. We can see person at, like at sign, 2D363FB3. That's super unhelpful. What we're actually looking at here is the memory address. Just like if you were to ask me where I lived, I would just give you my memory address. That's effectively what we're doing here. We're just saying, hey, where do you live? Where can I go to learn more about you? Where can I go to see your house, right? Whatever it might be. So I say, okay, person at 2D363FB3. Again, not helpful for what we're trying to get at, but it's doing exactly what we'd expect it to do if it was a human. A human would do the same thing. It would give you its address. It wouldn't just like show up with all your stuff. You'd have to actually go to that address to gather all the information that you needed. Okay, so let's figure out how to actually do that. There is something called a toString method. And now this method is automatically getting called by Java inside those print statements. So this print statement right here is technically a method, right? We see those round brackets that tells us it's a method, which means that there's probably some internal code right inside here. Go to implementation. Haha, I can't believe that worked. We can go inside the print stream class that's inside Java, and we can see that we're coming in and the toString is getting called right over here. It doesn't actually say .toString, but I promise you that that's what's happening here. If I go into here, and I go to that implementation of value of, we see it right there. We see a toString method getting called. So we can follow that all the way through. I am so excited right now. I've never done that before. I've never like followed that implementation through the Java classes, and I am stoked with how that turned out. So what that means is if I say, whoops, public string toString, and I give it a string is going to come back, right? We have a return type of a string, and it says, I am a person. What's actually going to happen here is my program is going to go ahead and call system.out.println, passing in my instructor as a parameter. And .println right here is its definition. Here's the implementation of it. We can see what's happening. We're going to have an object X happen right here. And technically, object S here is going to, it'll either go and do this one, or it'll do this one. We already saw what right line does, so let's just follow this one through. We go to this print method right here. We can see that the print method is right here, and it calls write string.value of. It leads us right back to that value of method. And when I go to that implementation, we can see that my variable, which just kept getting passed in, eventually ends up getting called object.toString or null, right? If the object is null, we just say null, which we've seen print before as well, like when our string was not initialized. And then here we can see the .toString actually printing out. So if I now say instructor, and I have written my toString method right here, I wrote a toString method so that it can actually get called, and I run this, we're going to actually get I am a person printing out at the bottom there. Now notice that before, when we didn't have a toString, our code didn't explode. All that happened was a default toString got called. And that default toString is just the memory address. That's all it is. Okay, so instead of just printing I am a person, right, we actually have to put some words in there that we want printing. Well, this was what we had printing before, right? We had the name of the person and how old they were. So if we actually go into the person class, and instead of printing I am a person, we print the current person's name is however old they are, we can now very easily, let me just move this out of the way and put the comment back there. Oops. This one can be kid 1, kid 2, and instructor. Rather than having this print line everywhere constantly being copy pasted, we can just print the object itself. Oh, my kid 2 is in here. I didn't realize. Whoops, let me bring that back out or it's not going to compile. Okay, there we go. And now we can get Evan is 5 years old, Allison is 0 years old, and Lauren is 30 years old. Notice that Allison is 0 years old because when she was created, we didn't actually set an age. So it defaulted to whatever the default for the int age variable was, which happens to be 0. And then we have a new baby name right here being set to Allison. So while her name was set, that's all that was set. Nothing else here was set. Okay. So we have defined it, and we get to control how our object displays a string. Now that it's just done, it's very easy for us to call this print line, pass in our object, and we see things come out exactly as we would want it to. The last thing we're going to say here about toStrings is that there's always a toString method when you don't supply one. And we saw that happen. We saw the default toString run when we didn't write our own. Of course, it was garbage, right? It was garbage that it spit out. It just spit out the memory address. The default toString will always print out the data type, so the class name, and then the memory address reference of the object, which is not that helpful for us. And as the course goes on, we're going to talk a little bit more about these defaults and how they work and what's going on here. Okay, so now at this point, we're going to do a little pause and practice. I'm going to ask that you go and create a video game character class. It should be in its own Java file. It should have a name, a string name variable, and an int hit points variable. You can also create a toString method, which is going to print all the information nicely. And then you can create a main class, which will make the video game character, and you can give them some names and some hit points, and just practice printing them out. Get that toString writing. Once you've done that, come back, and we're going to talk about constructors. Okay, this is where I would like pause the video. So pause it. And then I will say, welcome back. Welcome back. So let's talk about constructors. So right now, when we are creating our new person, we say new person, empty brackets, and then we set all of the person's information using different means, right? We can say kid2.age, we use dot notation. Over here, we set it by passing it in into a method. But in order to give each of our individuals, each of our objects values, we had to do every single one individually, which means we had to basically copy and paste these 3 lines of code every time we made a new object. First, we made the object, then we gave it a name, then we gave it an age. And if we had even more properties, more instance variables, other than just a name and an age, maybe we have a birth date, a favorite color, last name, a middle name. Like we could have so many variables. Having to write the same X number of lines of code every single time is a problem. And again, if you sort of clue into how this matches up with our toString, before we had a toString, we were copy pasting that print line hard coded string, and we told ourselves there has to be a better way to do this. I'm suggesting now you do the same thing here. You realize you're copying the same line, 3 lines of code, and there has to be a better way to do this. So let's do it. Let's do a different way. It's called a constructor. You can think a little bit about it like allocating the memory for an object. So we're not actually setting all of those values. We're just making space in memory for it. And normally we use it to initialize our instance variables so that we don't have to do it through this dot notation that we're doing right now. We can also do any kind of special processing that might need to be done when an object is being created. Perhaps you need to set some certain values, run some calculations, whatever it might be, we can do that on object creation instead of cluttering our main method with all of these different sort of components. So a constructor is a special case of an instance method. It does not have a return type at all, and it has to have the same name as a class. Right here, while this looks like there's a return type, when we actually write it, you'll notice that we don't have one. It is called using new, the name of the class, and then here we have these 2 brackets here. Now, when you say new class name, round brackets, what is getting called is our constructor. That is what's getting called. It happens automatically. Java sort of takes care of it when it sees the new keyword. It knows you're trying to call something that should be constructing a space in memory. So this is kind of what it looks like. Our constructor here previously looked like this, and this was the default one that Java gives us. You'll see there's nothing in these brackets. Here we're going to actually create a constructor where we do pass information in. So let's go over here. Public person. And we take in a string name and an int age. Just pause there for a second, come back over here. As soon as we create a constructor that has anything, as soon as we create our own constructor, we lose access to the default constructor. This doesn't exist anymore unless we explicitly make one, which we can do too. We can explicitly make a constructor, public person, with no variables because the method signature is different. Although the name is the same, the parameters are different. This one has 0 parameters. This has a string comma int parameter. So now our code still runs as it does before, but we still have these lines here, all these lines every single time. So instead, what we now want to be doing is we actually want to be passing this data into the constructor. And now we have to, think about it exactly like a method. We can get rid of these, get rid of these. So now on the other side of the program where our constructor exists, we're getting these 2 pieces of information, and we have to associate the information that's coming in with the instance variables, lines 1 and 2 up here. So to do that, we again can say this.name, meaning this current instance variable name is equal to name, and this.age is equal to age. And so now when we run this code, we will see that everything still works exactly as we would expect it to. When we go back to my program, this one didn't change because we left ourselves a default constructor. Typically, if you're going to leave yourself a default constructor, it's nice to give things default values, like name equals I don't have a name yet, and age equals 0. Something like that. It is a nice thing to be able to do. So then that way, for example, after kid2 gets created, if we try to print kid2, we're going to actually see I don't have a name yet is 0 years old. And then we'll see that when we actually update kid2's information through a baby naming and the age variable, we actually do get the updated information about that individual. All right. So we did define multiple constructors. We can see that here. Here's another example of the default one versus our constructor. You can also use different parameter names, just like any other method, to avoid those ambiguous conflicts so that you don't need the this dot. But again, personally, I find it to be better practice to keep things as consistent as possible. This just isn't descriptive enough to tell me what's going on. In a small program like this, it isn't a huge deal, but as programs get larger, this can become really hard to follow. So as soon as we supplied our own constructor, we lost our default constructor, right? We saw that. And as soon as we have a constructor, we actually have to use it properly. If we try to use a constructor that doesn't exist, for example, this other newborn constructor that passes in just an integer, it's not going to work. We're actually going to get a compile time error saying that no constructor method person exists with a single int parameter. Another quick note on instance variable values, if a constructor doesn't initialize those values, they will just keep their default value, which we did see happen. So if we wanted to remove our default constructor things here, and then we came here and we tried to print kid2, we will end up with null is 0 years old once again, as we can see right down there. Okay, I'm going to put those back though, because this is this is better practice. Okay, so we did originally have a default constructor that was provided by Java, and it will stay as long as we don't define our own. But as soon as we define our own, we lose it, right? We saw that it disappeared. We didn't have access. We had to explicitly define a default constructor after defining any version of constructor at all. So it compiles with no errors when nothing was there, but as soon as we made a constructor, even though it isn't a 0 parameter constructor, we got cannot find symbol constructor person with no parameters. So we had to define it ourselves. All right, so at this point, we have covered everything we needed to meet our learning goals for this topic. So let's do a little bit of practice. Let's create a Java class named animal, and you're going to have a name and a number of legs. You're going to create 3 different methods here. You're going to create your constructor so that it actually passes in the name and the number of legs as parameters and initializes them appropriately to the instance variables. You're going to write a toString method with the format that I give you, and it's really important to follow that format. And then there's also a sit method, and the sit method here will not return anything, but basically it will just print out a system.out.println message with the name is sitting. So if the animal's name is Fluffy, when you call the animal.sit, it should say Fluffy is sitting, right? I've already added a main method in umlearn so that you can test this animal class that you're writing with, and this will be great practice for the assignments as well. So give that a shot, and then once you feel nice and comfortable with the basics of objects, you can meet me in the next video for the next sort of layer of complexity when it comes to programming objects in Java. Thank you, everyone.